1. The 16 trillion promise on the ocean floor. The deep ocean floor holds a hidden fortune. It is vast, it is dark, it is cold. Down on abyssal plains, scattered across the seafloor, lie trillions of potato-sized rocks. Scientists call them polymetallic nodules. These nodules are not ordinary stones. They are rich in metals essential for modern life: nickel, cobalt, manganese, rare earth elements. Some estimates value these reserves between $8 and $16 trillion. That number has captured the attention of governments and corporations around the world. They see a new frontier for resource extraction, a solution to a growing problem. Demand for these specific metals is soaring as we move away from fossil fuels and build a clean energy economy. The deep sea seems to offer a ready answer, a seemingly endless supply for our green future. On land, mining devastates landscapes, pollutes water, and displaces communities, often in unstable regions. But a new rush forces hard questions. How do we balance resource needs with protecting one of our least understood ecosystems? Section 2. How to mine the bottom of the sea. The process of deep-sea mining is a feat of modern engineering in the abyssal zone, thousands of meters down. Here, there is no sunlight. The pressure is immense. The water is near freezing. Targets are polymetallic nodules lying loosely on soft sediment. Companies plan to deploy massive remote-controlled robots, seafloor collectors, robotic harvesters. Like giant underwater vacuums, they crawl and systematically gather nodules. A riser hose connects harvester to support vessel, pumping slurry of nodules, sediment, and water to the surface. On board, nodules are separated and stored. The operation is remotely controlled from ship consoles. What remains is a waste stream called a return plume. Release options include near-surface discharge or pumping to mid-water depth. Its contents and temperature differ from surrounding waters. Dispersion and impacts are a major concern. This method is new. Large-scale reliability and consequences remain unknown. Proponents call it clean and efficient. Critics call it a massive, untested experiment. Section 3. The global race for seabed minerals. This race is not just about technology, it is a geopolitical contest. China has been particularly proactive, holding 5 ISA exploration contracts. 3 of these are in the Clarion-Clipperton Zone, a nodule-rich Pacific expanse. In early 2025, China and the Cook Islands agreed to collaborate on seabed minerals. The United States is making bold moves to assert its dominance. A U.S. executive order cited national security and economic interests to fast-track leadership. Days later, the metals company submitted the first U.S. commercial mining application. Its CEO expressed confidence in securing approval, signaling private industry's push. Norway's Arctic plans faced criticism and were deferred in late 2024. Japan invests heavily in deep-sea mining technology and research. Pacific Island nations see potential revenue but face ecosystem risks. Section 4. The economic allure of the abyss. Analysts project a meteoric rise for this industry. A Data & Intelligence report forecasts growth from $3.92 billion in 2024 to $40.79 billion by 2032, a 34% CAGR. Such rapid expansion is fueled by demand for the green transition, electric vehicle batteries, solar panels. The appeal for investors is obvious. Seafloor metal reserves, 8 to as high as $16 trillion. Firms like the metals company bet nodules are highly concentrated and cheaper to process, with lower footprints and higher margins. Nations see economic security, reliable mineral supply independent of foreign control. However, metals markets are volatile. Recent surpluses challenge assumptions. Cobalt and nickel surpluses persist. Nickel fell over 7% in 2024. Only 20% of 2024 China EVs used cobalt-containing batteries, undercutting demand. With huge upfront costs, profits depend on high prices that may never materialize. The deep sea is the largest and least explored biome on Earth, home to stunning, unique, slow-growing life. Adapted to darkness, high pressure, and stability across millennia. Deep-sea mining threatens to shatter this ancient, tranquil world. Massive machines scrape and destroy everything in their path. Centuries-old corals, filter-feeding sponges, and countless small creatures are lost. Mining kicks up plumes that drift for miles, smothering life and cutting off food and oxygen. Filter feeders clog. Distant habitats are buried in fine silt. Noise and light disrupt a world that was dark and silent, altering behavior and survival. Impacts extend into the water column via pumping and waste discharge. The return plume of cold water, sediment, and crushed fragments is released back into the ocean. Toxic metals can spread through the food web. Chemistry and temperature shifts harm plankton. Effects can ripple to commercial fisheries and ocean health. One analysis estimates damages up to 25 times land mining and costs up to $500 billion. Section 6. The fate of the deep sea is being debated at the International Seabed Authority, the ISA. The ISA regulates mineral activities in international seabed areas, a common heritage of humankind. Its mandate: organize and control mining and ensure effective environmental protection. Years of work on a mining code for standards, financial terms, and oversight have stalled. Some states push to finish quickly. Others call for a halt or moratorium. More than 24 nations urge a pause. Over 900 scientists have signed a statement. A 2-year rule set a July 2023 target. A new July 2025 deadline also passed without agreement. The legal gray area raises pressure as firms could seek provisional licenses. The world is divided, and the ISA is caught in the middle. It is a fraught moment. Section 7. Advocates frame seabed mining as a better alternative to land mining. Land mining brings deforestation, erosion, water contamination, toxic chemicals. It can spur social conflict, displace communities, and create hazards. Seabed mining avoids forests and settlements. Robots do the work. But the comparison is fraught with unknowns. Land harms are visible and partly mitigable. Deep sea damage would be hidden and not restorable. Reports suggest biodiversity damage up to 25 times greater. Plumes may affect vast areas. Toxic metals, noise, and light could produce far-reaching, unpredictable effects. We have decades of land regulation experience, but are starting from scratch at sea. Rather than a false dilemma, focus on recycling, material-efficient design, and chemistries that reduce demand. Section 8. As the debate intensifies, 3 paths emerge. Path 1. Prioritize scientific research. We do not know enough. Map biodiversity, understand life cycles, model long-term impacts to inform regulation. Path 2. Strict regulations. Finish the mining code, set large protected zones, require best tech, enforce monitoring. Path 3. A precautionary pause, a temporary ban on commercial deep-sea mining. Supported by over 24 countries and more than 900 scientists, these paths are not mutually exclusive. A moratorium could frame intensive research, which shapes robust rules. But economic and political pressures demand decisions now. Companies are ready to invest. Governments want secure resources. The choice will carry profound, lasting consequences for the ocean and the planet. It requires careful deliberation, not a race to the bottom. Section 9. We stand at a critical crossroads. The deep ocean, dark, mysterious, more than half our planet, is on the brink of industrialization. The $16 trillion question is about the values we choose to uphold: short-term gains and resource security, or caution to protect a last wild place. These minerals promise to fuel a cleaner energy system, but there is irony in destroying a stable ecosystem to save the planet. The risk of irreversible biodiversity loss and pollution may be too high. We must ask if there are better ways to reach our green goals. Pursue a circular economy, longevity, recyclability, metal recovery from phones, laptops, and cars. Innovate new chemistries, align investment, policy, and consumer choices. It is harder than sending robots to the bottom, but more sustainable. The deep sea is our common heritage. Our choice should honor the immense, silent, vital world below.